Okay, this is Unit 5, Lesson 1, Day 2 homework, question number 29. It's in the review section. We're going to expand each of the expressions to an equivalent standard form of a quadratic. Now remembering that the standard form of a quadratic looks like ax squared plus bx plus c. So you want the quadratic part first, linear part second, constant third. So for part A, we're given the expression of two linear factors, x plus 5 times 4x minus 3. There's lots of ways to do this. You can use a foiling method, you can use a distribution method, you can use a boxing method, whatever you prefer. I think for this one, I'm going to start off by using a boxing method or a Punnett square looking method. To do that, I'll put each of these terms above a box. So this is x plus 5, and this will read 4x minus 3. X times 4x becomes 4x squared. 4x times 5 is 20x. X times a negative 3 is a negative 3x, and then 5 times a negative 3 is a negative 15. But remember, I want to write it out as the standard format, so I'll put 4x squared first. 20x minus 3x is a positive 17x, and then minus 15 is at the end. There's your standard form. Part B reads 5 times t plus 8 times 4 minus t. This time I'm going to do let's do some expanding with some distribution property first. So I could do this in lots of ways, but I'm going to take care of this 5 that's in the front. I'm first going to I'm going to distribute the 5 into one of the expressions. So 5 times t becomes 5t, and 5 times 8 becomes 40. So I have 5t plus 40 times 4 minus t. At this time, I can go back to the boxing method I want to, or I can do some distribution. So I'm going to go ahead and do some foiling this time, actually. And so I'm going to take my first terms, 5t times 4. 5t times 4 becomes 20t. And then I'm going to take my outer terms. Now again, I'm using FOIL. So this is an acronym for first terms, outer terms, inner terms, last terms. So my first terms were the first in each of the linear expressions. So 5t times 4 was 20t. My outer terms are the outermost from the center. So 5t and a negative 4 become a negative 5t squared. And I do my inner terms. I should probably mark those. Those are my outer terms. My inner terms are 40 times 4. 40 times 4 would yield 160. And then my last terms, the last in each of the linear factors, 40 and a negative t become a minus 40t. Okay, I want this in the standard expression, so I want to write the negative 5t squared first. Combine the 20s, 20t, or the t's I should say, 20t and a negative 40t become a negative 20t. Put the constant on the end, and this is your standard form. I'll box that in as my solution this time. Part C, this reads x plus 3 times x minus 3. This time I think I'm going to show you the distribution method just to make sure we're using that. So what I'm going to do is distribute this whole front term to both of those pieces. So it'll become x plus 3 times x, and then I'll have to do a subtraction, because the subtraction sign is there, minus x plus 3 times 3. Well, then I have to do another distribution. I have to distribute that back inwards. So I have x squared plus 3x, and then this is going to be, careful with the minus sign here, this will be a minus 3x, and it'll be a minus 9. So x squared minus, or 3x and minus 3x become to 0, and then minus 9 becomes x squared minus 9 is my final solution. That's one method. That's a method I think that is most mathematically sound. You're distributing the x plus 3 to both of these linear factors, or both these factors, and then you distribute this factor back into those. That's the most linear, or the most useful part of the distribution property, but we come up with shorter cut methods like FOIL and the boxing method that work just as well. Part D says that 2 times s minus 7 squared. According to the order of operations, I have to do the squaring part before I multiply by this 2. So s minus 7 squared really means s minus 7 times s minus 7. All right, so I'm going to take care of that part first. I'm going to go back to my boxes. I like to use those. S minus 7 and s minus 7. S times s is s squared. This is a negative 7s, a negative 7s, and then this is a positive 49. So I write that out. I have s squared minus 14 s's plus 49. But then I've got to make sure I multiply by 2 that was still out front. Okay, so that 2 needs to come, and this becomes 2s squared minus 28 s's, and then I need to double 49. Double 49 is going to yield 98. And then there is the standard form. Okay, 2 more to go. E, I have 3s plus 2 squared. Okay, common error, don't do this. Don't just square the 3s and make that 9s squared and square the 2 and get 4. That is not the same. That's bad, don't do that. Okay, what you need to write instead is 3s plus 2 times 3s plus 2. And then you can do your foiling method or box method or whatever you prefer. I, again, prefer the boxes, so I'm going to put 3s plus 2 here and 3s plus 2 here. 9s squared, 6s, 6s. 2 times 2 is 4. The result then is 9s squared plus 12s's plus 4. One more to go. F. This last one has a fraction in it. Don't be afraid of the fractions. They all work the same. I have y minus 5 halves squared. Again, I don't want to just square each part. This is equivalent to y minus 5 halves times y minus 5 halves. Okay, I'm going to use the boxing again. So I have y, and a negative 5 halves and a negative 5 halves. Y times y is y squared. This is a negative 5 halves y, a negative 5 halves y. Now this part, when I do a negative 5 halves times a negative 5 halves, when I multiply fractions, the top's numerators multiply and the denominators bottoms multiply. So this is negative 5 times a negative 5, which is positive 25. 2 times 2 is 4. So this becomes 25 fourths. Put it all together, I have y squared. The combination of these two is actually going to be a negative 5 halves plus a negative 5 halves. This time, when I'm adding fractions, the denominator stays 2. The numerator adds together to be a negative 10 halves. Well, negative 10 halves reduces down for us, and that reduces to a negative 5. So I have y squared minus 5y, and then I add on that 25 fourths. And that is my final answer for 29.